Hey guys, this is Emil Fernandez. I just wanted to take a minute or so to go through the low fidelity visualization work I did for the RBE 501 Bricklayer project that we did. As you can see, I'm one of 6 folks on a team group for this group project. Other members include Kathy, Carl, Brian, and Jean. At the beginning of the semester, we chose MATLAB 3D animation over ROS and Gazebo. And one reason we chose that is that we found this great example, which I could almost consider a gold standard, for representing a robotic manipulator in MATLAB 3D animation tied back to a Simulink model. This is a specific representation of a Manutech manipulator. So before going a little further, I actually want to give a little bit of context of sort of the breadth of what we were trying to do in terms of modeling and simulation for the Bricklayer project. Specifically, I want to start out with the fact that we were trying to use the material we learned from class, determining the arm kinematics, arm dynamics, base kinematics, and base dynamics based off of calculations. And we started from there. From our class, we learned that we could actually take these arm kinematics and base kinematics and combine it into, well, combined kinematics and combined dynamics for the manipulator arm sitting on top of the base, so a mobile manipulator. On the other side of the calculations, we actually started out with CAD drawings and SolidWorks drawings of the 2 arms that we had actually selected as manipulators, as well as a CAD of the create base. Starting from the CAD, we knew the procedure of how to pull it into Simulink to create MATLAB to create a SimBody arm and a SimBody base model. And we also had a procedure that was delineated on how to pull it into a VRML world representation so that we could have it being visualized and potentially interacting with other virtual objects. Unfortunately, we didn't realize how challenging this is. While the procedure seems simple, there are nuances to it that, if not done correctly, make it difficult to get things properly created. One of my other team members continue to tackle this pathway of building out the SimBody arm model and SimBody base model, as well as pulling it into the virtual representation of the world throughout the whole semester. From the SimBody arm model and SimBody base model that we would get from the CAD once pulled in, our goal was to combine it into a single SimBody model. Even if we build a combined SimBody model, it cannot actually drive the VRML representation on its own. You actually have to build a sort of a linking Simulink model that would take those outputs and drive the VRML model. So after all that, we would have the combined kinematics, combined dynamics, combined SimBody model driving a Simulink connection to the VRML world and seeing our output as a visualization in the VRML world representation. That is the ideal case. What I was doing for the team was trying to build out specifically the Simulink model driving the VRML representation. As you see here, we have the CAD of the snapper arm. We also had CAD for the create base, and we also had a SolidWorks model built by one of our team members, Jean, for the OWI arm. What was the challenge, though, was trying to actually bring all this material into a SimBody model and the VRML. Brian Burdett was continuing to try to take the CAD and pull it into the SimBody representation, or SimBody, to create a model, as well as pull it into the VRML. I actually took the parallel route of trying to do it from what I consider a low fidelity representation, which is, well, I'll explain in just a second. So from the CAD and from the hardware implementation, I actually created an approximate representation of the robot arm and robot base combined using just cylinders, boxes, in the proper configuration. And this is what I call the low fidelity model, since the level of detail is just lower than what would be coming from a CAD representation that's pulled into the VRML. What you see here is the Simulink that's actually driving the VRML representation. And from left to right, it's actually two boxes, one comprised of a profile of the X, Z, and rotation of the base, which is actually the full robot in time, and separately is joint profiles over time that are driving the movement of the arm representation. So unlike Gazebo, which actually has built-in physics engines, the MATLAB 3D animation and Simulink, well, the VRML world space does not have innate forces or a sense of physical boundaries in it. So any type of interaction between an object that you create, say a virtual brick, and our robotic arm, all of the handling of forces, interactions, and whatnot would have to be created and handled in the Simulink itself. It is not in the VRML representation. What you can get from the VRML in the world space environment is a sense of position, even velocity as outputs of it, and rotation. But you will not get any type of forces, you will not have force interactions unless you specifically sort of build that out in the Simulink itself. And that is the second part of the Simulink code that is represented here. And so the end result is a visualization of the VRML robot picking up a virtual brick and moving it from the start place to the end place as we had planned. So the value of doing this visualization, even though it is low fidelity, is that we were able to confirm that a comparable sort of joint pose was needed to pick up a brick based upon the configuration of where the brick is and in relation to the robot, as well as we were able to see, you know, what's the ideal base and joint profiles that would be needed to accomplish this specific action. I mean, this is a starting point. It is not the end point. You could do assessments on the joint trajectories and determine if the velocity and acceleration profiles that are associated with it are feasible based upon the hardware. You're able to, from there, sort of test out different trajectories. And ultimately, this should be driven out by the SimBody model of a combined system that was created from the CAD. And, well, you can go a long way from here, and this was just really scratching the surface of what could be done ultimately with Mod and Sim for this robot. I want to thank my group members. It was actually a lot of fun working on this project, and in general working with them in this class. And as just a going away thing, I just wanted to share a smaller mini video, if you're still here, as a going away gift. Thanks.